Welcome back to another MECH 1000 video. We are in Unit 8 of the Blueprint Reading textbook, and we had just left off talking about different section views, and in this example it contains some annular grooves in which we answered some questions, and now we are moving on to finding the wall thickness of a pipe, tube, or other hollow cylinder. So this is something that we have looked at before, but perhaps not while considering MMC and LMC. So if we want to find the wall thickness of a pipe, and we know its outside and inside diameters, we can find the wall thickness by taking the outside diameter minus the inside diameter, and then we need to divide by 2. Students frequently forget to divide by 2, but if we just took the outside diameter minus the inside diameter, what we would be left with is the thickness here as well as the thickness on the opposite side. So in order to find out just what one wall thickness is, that's why we need to get rid of that by dividing by 2. And that leaves us with the wall thickness. Now when tolerances come into play, if we are at MMC, that means maximum material condition, the outside diameter gets larger at MMC because this pipe is made of solid material, and if there's more of it, then the outside diameter is going to get larger. It also means that the inside diameter is going to get smaller. We're going to have a minimum inside diameter with a maximum outside diameter. So at MMC, this wall thickness is at its largest. Whereas at LMC, least material condition, we have the minimum outside diameter, and the inside diameter is at its largest. And so at LMC, we have the thinnest allowable wall thickness here. So if we wanted to calculate the maximum wall thickness, the maximum wall thickness would occur when this is at its largest. So this would be 1.01, 1.00 plus the 0.01. And when the inside diameter is at its least, its smallest, 0.74. And so to find the wall thickness, we would take 1.01 minus 0.74 and then divide that by 2. That should give us 1.35. Now if we want to calculate the minimum wall thickness of this pipe, that would occur when the outside diameter is at its smallest, so that would be 0.99, would be the 1.00 minus 0.01, and when the inside diameter is at its largest, 0.75 plus 0.01, or 0.76. So then the wall thickness would be 0.99 minus 0.76, divide that by 2, and that leaves us with a wall thickness of 0.115. Okay, moving on to a completely different topic. We're going to talk a little bit about materials. Now, this is not a materials class, but we do need to be aware of some terminology that we may see on some drawings. So cast iron is a material made from iron, carbon, and silicon. And there are different classifications of cast iron depending on the proportions of its constituent materials and the way it is processed. These types of cast iron include gray iron, white iron, malleable, and nodular or ductile. cast iron, and so that's just something that is typically found in the title block of a drawing, the material that is used to make it. Just something to be aware of when reading drawings. Okay, we're kind of skipping around on topics here, so again, on to something completely different here, and that is the concept of spot facing. So a spot face is very similar to a counterbore. It's made in a very similar fashion. Typically, you have a hole. Oftentimes, it is drilled, and after it is drilled with a drill bit, you come back with a specialized tool that sits down into that tool, and then these splines remove material from the surface of that hole, leaving what is essentially a very shallow counterbore. Now, really, the only difference between a spot face and a counterbore is its intended function. So a counterbore is meant to be deep enough to receive the head of a fastener, like a bolt. So you might have a deep counterbore and a through hole, and then you would have a fastener like a hex head bolt or something that would actually sit down inside of that counterbore, leaving the top surface flush. A spot face, on the other hand, is just meant to provide a nice, smooth surface on which the fastener can be tightened down. So this is sometimes necessary when you are using a material like cast iron, because the surface of cast iron can be rough. And if you had a rough surface, kind of exaggerate here with my sketch, and you had a head of a bolt that went into a hole and you tightened it down, what would happen is the pressure from tightening the head of that bolt would be resting on all of these high points, and that's going to cause high stress areas, which can then lead to cracking or breaking the material. So a spot face removes those high points and low points and replaces it with a nice, smooth, level surface on which a fastener can be tightened. Now, the depth of a spot face is standardized. You're not going to see that information on the drawing anywhere. So if you come across a question that asks, what is the depth of the spot face? You're not going to find that information anywhere on the drawing. You just need to know that it varies from somewhere between 0.03 to 0.06 inches. So let's look at an example drawing here. What type of section view is drawn? So this is the section view. We can see these diagonal section lines on the top and the bottom, on the left and the right. So it is a full section. What is the tolerance on the reamed holes? So a reamed hole is one that has perhaps been cast into place, or it could be drilled, but drill bits are not as precise as a reamer would be to come back and remove material from a previously existing hole to make it a little bit larger in diameter and a little bit more precise in diameter. So here we see the abbreviation of RM for ream. So this is the reamed hole, and its dimension is given with limits. This is the minimum, and this is the maximum size. So the tolerances down here don't really apply to this hole. So instead, when we're asked for the tolerance of a dimension given with limits, we simply need to subtract the smaller dimension from the larger. So 0.8130 minus 0.8125, and that gives us 0.005. And we do not need to put actually that's point, I left off a place there, didn't I? 0.0005, and we do not need to show it with a plus or minus. It's not plus or minus, because it's just, this is the difference between the largest possible maximum dimension and minimum dimension. So we say that that tolerance is 0.0005 without the plus or minus. What is the MMC of the reamed holes? So remember, it's understandable that you would think M maximum and want to go with the largest, but holes are smaller when they have more material surrounding them. So MMC is the smaller of the two dimensions, 0.8125. What would be the overall height before machining? So this is a cast. We can see it's made from malleable iron, which is a type of cast iron, which means this is a cast part. And castings are rough and sometimes need to have surfaces removed, such as we see here at the bottom. The bottom surface of this part has these symbols on it, these finishing symbols, meaning that they needed to be machined. And so that means there must have been a finish allowance on here when it was first cast that then is removed so that we can end up with these final dimensions. So we need to find what is the overall height as it is now, and then add on to it the finish allowance. We have here the dimension from the bottom to the center of this hole, and we have here the diameter of the hole. So if the diameter is 1.36, then its radius is 0.68. And so if we take the 1.940 and we add to it 0.680, we get 2.620. And then the finish allowance is 1/8 of an inch, or 1/8 equals 0.125, but we frequently round that off to 2 decimal places and just call it 0.12. So if we add to that the finish allowance of 0.12, that brings us up to a total of 2.74. And that 2.74 is the final answer. That's the height of this part before machining was done. What is the approximate depth of the spot face? This is what I said is not going to be shown on any drawing. This is just a standardized depth that you need to be aware of. It is between 0.03 and 0.06. I think this might be a good place to stop. We're going to kind of transition back to talking about section views, and I see I only have about 2 minutes left in this video, so I'm going to cut it a little bit short so that we can hopefully finish this up in the third video.